14.1 trigonometry. We're going to deal with right triangle trigonometry to start with. We will eventually move into trigonometry that goes with any triangle, any angle. So, if I have a right triangle, I have one of my acute angles labeled theta. By the way, what is an acute angle?
Right, less than 90 degrees.
Less than 90 degrees.
Good guess.
So, for right triangles, our trig functions are always values, guys, are always values of angles less than 90 degrees. I'm going to change that, but right now, that's what we're going to do. So, when you look at the angle theta, I need to label the three sides of my right triangle. When I look at it, I have this angle right here. I look at the side that is not touching the angle itself. That is always the opposite leg. OPP stands for opposite leg. I look at the other leg of my right triangle. It's the one that is touching the angle. So I'm going to label that ADJ for adjacent leg. And then the third side of the triangle is the hypotenuse. I'm going to label that HYP for hypotenuse. So those are the three sides as they relate to our trigonometric functions. Now a reminder, if I use this angle up here, everything changes. The hypotenuse stays the same, but the adjacent becomes the opposite becomes the adjacent. So identifying which angle it is you're finding the trig function for is essential. Okay, so the sine of theta is defined as the length of the leg opposite divided by the length of the hypotenuse. So that is opposite over hypotenuse. The cosine function is defined as the length of the leg adjacent to the angle divided by the length of the hypotenuse. Or in shorthand, adjacent over hypotenuse. The tangent function is defined as the ratio of the two legs of the triangle. So it's the length of the leg opposite divided by the length of the leg adjacent. In shorthand, opposite over adjacent. Okay? Hopefully those all look pretty familiar. Seen those before. Okay? Now we're going to look at the reciprocal functions. The reciprocal functions are reciprocals of our original three. First we have the cosecant function. It's abbreviated CSC, and it is written, or it is the reciprocal of the sine function. So it's 1 over the sine of theta. So that would be the length of the hypotenuse divided by the length of the opposite leg, or hypotenuse over leg, or hypotenuse over opposite. Okay, the secant function, abbreviated SEC, is the reciprocal function of the cosine. So I have the secant of theta equals 1 over the cosine of theta, which is the hypotenuse divided by the adjacent leg. The cotangent function is the reciprocal of the tangent function. So that is the adjacent over opposite?
No.
Um, okay, so questions on these. This list is one that you need to commit to memory because we use it all the time. If you don't already have it memorized, do so because it's very important. Okay?
Is that like a sign and an O at the end of it?
A sine theta. Okay. If you don't have these memorized, what I would do is write the list on either on a separate sheet of paper or on the side of your assignments. You can refer to it, and we're going to do enough of these that they will become second nature. So, are we ready? Got it, Bobby? You're still working. So, a couple of different types of problems you're going to look at for today. One is you're going to be given a triangle. By the way, on every problem, I expect to see this triangle drawn on your paper. Don't need graph paper. It's just a sketch. Okay. So I have a right triangle. I am given that the length of one leg is 5. The length of the other leg is 12. I need to find the length of the hypotenuse. So if I label them this way, first thing I need to do is figure out what is the length of my hypotenuse. So I'm going to use the Pythagorean theorem. A squared, B squared, C squared. So I have 5 squared plus 12 squared equals C squared. 25 plus 144 is C squared. So 169 is C squared, so C is 13. Now, again, referring to what you already know about right triangles, if you remember that 5, 12, 13 is indeed a Pythagorean triple, you can skip that part. Okay, if you don't remember, you just do the Pythagorean theorem and it's always there. But
I remember like 3, 4, 5.
everybody should remember 3, 4, 5. That should be an easy one you remember.
That was a 20 on that.
Okay, so now make a list of our 6 functions.
Do we need to write that little thing on top?
Yes. The theta has to be included in all of them. Here's why.
Okay.
Because, let's say I have the other angle over here labeled alpha.
That's a fish.
That's an alpha.
Alpha. Alpha fish.
Then the sign of alpha is different than the sign of theta. So you need to be sure to use
I'm not doing that this year. I'll take it. I'm doing that this year.
Okay. So, the sign of theta is, got your list handy? Opposite over hypotenuse. So here's theta. Let's label our sides. This side is opposite.
Is theta always going to be labeled for us?
Yes. Well,
Opposite.
and this is the hypotenuse. So opposite over hypotenuse is 12 over 13.
I'll take that.
Okay? The cosine is the adjacent over the hypotenuse. So that's going to be 5 over 13. Tangent of theta is opposite over adjacent. So that's 12 over 5. Cosecant of theta
13 over 12.
is the reciprocal of the sine of theta.
That's really easy.
So it's the hypotenuse over the opposite. So it is 13 over 12. The secant of theta is the reciprocal of the cosine. So it's adjacent over hypotenuse. So it's 5 over 13. Oh, sorry, 13 over 5. And the cotangent of theta is the reciprocal of the tangent, so that will be 5 over 12.
You want
Okay.
round it to their count?
What's that?
We round?
Don't round anything.
We don't do
Everything will be exact values. If you have a fraction, it will be simplified. And as we'll see in the next example, if you have a root,
Oh, so
it
you
will
don't,
also be simplified. No decimals, all exact values.
oh, so you don't even want the, that's the,
This is exactly what I want. You're going to have 6 answers for each problem.
what do they do that calculate?
Probably don't need it.
Good.
Okay?
Always our time.
So today we're going to do all exact values. Questions on this one? Okay. Last one again. I expect to see pictures drawn with these. We're given a little sentence, a short story problem. If theta is an acute angle of a right triangle, and the sine of theta is 4 over 7, find the value of the other 5 trig functions. First thing you do is draw a right triangle. Okay, and in your right triangle, you decide which angle you want to identify as theta.
It doesn't really matter.
Doesn't matter.
I like it good.
Now, keep in mind, since you're kind of drawing these blind, your triangle is probably not going to be drawn to scale, and that's okay. All you need to know is, okay, if this is theta, then this would be the side opposite. This would be the side adjacent, and this would be the hypotenuse. Now, since the sine of theta is 4/7, and I know that is opposite over hypotenuse, then my opposite I'm going to label with a 4, my hypotenuse I'm going to label with a 7. So now I know two sides of my triangle. I can find the third side. So hypotenuse is always the C. The other two legs are interchangeable. So if I say a squared plus b squared equals c squared, then a squared plus 4 squared equals 7 squared. A squared plus 16 equals 49. A squared equals 33.
So then what?
A is the square root of 33. And you will leave it as a radical. No decimals. So now I'm going to write my other 5 trig functions. So I have the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. Now, cosine is adjacent over hypotenuse. So look over here and say, okay, my side adjacent is root 33.
Over 7.
The hypotenuse is 7. So this is root 33 over 7. Okay. Tangent of theta is opposite over adjacent. So that's going to be 4 over root 33. Now, if you remember your rules about radicals and fractions, we never leave a radical in the denominator.
Right.
So we need to multiply the top and the bottom
By 33.
by root 33. So I have 4 times root 33 is 4 root 33. Root 33 times root 33 is just 33. And that's the answer I want for the tangent. Cosecant is the reciprocal of the sine, so it's the hypotenuse over the opposite.
7/4.
So it's 7/4. The secant is the reciprocal of the cosine. It's the adjacent over the hypotenuse, so that's going to be
7 over root 33.
7 over root 33.
I'm sorry, root 33.
Now, so you're going to multiply that by root 33 over root 33, and you get 7 root 33 over 33. That's the form I want it to be left in. The cotangent of theta is,
Do you take the original of tangent, or you take the simplified form?
go back to the original or else go back to your triangle. It is the adjacent over the opposite, and you have root 33 over 4. Which you could go back to the simplified version, but if that happens, you're going to have to do more simplifying. It's way easier just to go back to the beginning. So those are your 6 solutions. Any questions? Okay. That's all your notes for today.